talk.
Hi,
This meeting is
Jennifer
being
Roberts.
recorded.
I teach at Camas High School.
And
this year I'll be teaching
we're
AP
gonna talk
Environmental
about
Science and
the
3
week at a
courses of
glance.
that and 2 Anatomy and Physiology.
So
this is a practice run to see
Joe,
if I
are you in here?
can look at lighting and sound quality
Continue
and
to
figure out the features of the video.
does work. You just have to log in from the school account. Otherwise, it won't let you in. It's a new portal to come through, so we don't have Zoom bombing. All right, so I'm going to select your week at a glance, and we're going to talk about it because there's a couple changes if you happen to have looked at it last week. We are on slide 6, which means progress reports should be coming out soon. What is all the, oh, that's people saying stuff on Google Classroom. All right. Let me go respond real quick to some. There they go. Thank you, Grace. If you guys could keep talking back to the little dings will stop, but this is what I hear all day long. To see, this is what it sounds like when 150 of you are sending me messages. All right, so they'll eventually hopefully get on their school accounts and get in. I see 3 more of them getting in right now. All right, so back to where I was, week at a glance. Those of you just getting in, just be aware I am recording today for any students that don't get in or don't get switched over to their school account. I don't know as a parent, I don't remember, I don't distinguish anymore which emails are coming to which, if but I thought there was an email that went out on Parent Square that warned you guys of Clever portal, but maybe not. All right, so week at a glance, let's look at this. It says, discuss week at a glance, video optional. There is no video. Right now, my Edpuzzle is missing, meaning my 5 years of work at watching videos and embedding questions is completely empty, and it tells me I have no content. My daughter tells me from a student perspective, it's still there, that you guys can see Edpuzzle, but I don't have anything. So and there is no way to talk to a real person that I've found yet. So I'm hoping to resolve that within a week. Otherwise, I have to make a whole new. And I don't even want to think about that, actually. So somebody start texting those people. Yeah, they can't get into Zoom. They're gonna have to make sure they're on their Chromebooks and that they're using their school accounts. There's another one. I think it's just gonna, there we go. It's just an extra safety step. Anyways, that meant I had to take all your Edpuzzle stuff for this week, because I don't think in APES I ever got to the next week yet. In my anatomy, I had already looked at October 11th. But I don't think in APES I had, and there's absolutely no way for me to see anything now. So even though it looks like it's functional, right now for me, it's completely empty. So what we're gonna do is a TED Talk instead this week. Oops. Sorry, I'm still trying to get people in. So if you look at this over here, it says whiteboard review. We're gonna do the first 16 slides of chapter 2, which is a basic chemistry review. No problem, Samantha. I know everybody's going to kind of struggle. It's a little one extra step that they're putting in. And number 2, then we're going to talk about tagging. So kind of the format we'll use when you guys give your feedback. And then we will do quizzes. So we'll look at, I never like you guys to forget the previous topics. So we'll be doing it on chapter 1. And whenever we have a test, there'll be a section usually that will be a review section on what we covered the previous chapter. So that's 27 of you. Just got some more of you in. So your on-demand day is you're going to watch a TED Talk. It says fill out this form, and that is a PDF. Now the problem is it's a PDF, and if you convert it to Word, it makes a big giant mess. So if you don't have a printer, then just number on a Google Doc 1 through 12, and that's what it says on your classwork page. So there's 12 boxes that you normally fill out, but it does not convert. And as far as I know, I don't have the ability to convert PDF to Word at our school. So you're going to have time on that day. I want you to tag at least 3 other students' work, and we'll talk more about that here in a minute. And then you're going to read and take notes on Module 4, which is what we're going to go over today on whiteboard. So hopefully you'll see it today, and then you'll see it again tomorrow. Okay? The more you see it on a daily basis, the more likely you are to start remembering it. Day 2, I'm going to have to change this. It says go live, which I can't do. I just tried that this morning to see if I could do it, and I can't do it without recreating all of your accounts. So we will watch a special on Florida Everglades. It just won't be through Edpuzzle. It'll just be through my machine and my screen. And then we're going to start talking about biodiversity. So we're going to start building our background knowledge for our lab. I'm just looking to make sure there's nobody in the waiting room. Okay, so, and then on demand, you're going to time yourself. We're going to do another FRQ, 200 from 2012, question 3. Read and take notes on the case study, because what I want to do is have one day after another where you see the Florida Everglades. So here we'll watch a video clip about it, and then the next day you'll take an FRQ about it, read about it. So hopefully that's 3 different ways of seeing information about the Florida Everglades. And then correct your FRQ before Sunday. And then it says no school Friday. Your homework is just to continue to read and take notes on Module 5 as needed. All right, any questions on that? These are all hyperlinked, and including where it doesn't even look like it's hyperlinked. That was a mistake. But if you click on here, for example, what we're about to do now, which is talk about whiteboards, it's all hyperlinked. Okay, some people sound like still having problems. Okay. So everyone should be on the whiteboards. I see Aiden, Braden, Danny. Danny's on there twice. Femboy, I'm assuming that one of them's your brother. Haley, Joseph, Kendall, Maddie. Oh, and then you guys all shifted because somebody must have robbed you, Sammy. Oh, that's, well, I can't tell because you guys shift places every time one new person joins. All right. Any questions about the weekly agenda before we do a whiteboard review? I'm recording this because sometimes students will say, you didn't say that. You didn't talk about week at a glance. And I'm pretty sure I do. I always start a week the same way. I'm going to also start having a actual record of what I do, what I say. All right. Let's do it. We are going to do our whiteboards, and I'm going to share with you the chapter. Oh, I always go through a week at a glance. So let's go open it and get to it. So this chapter is called Environmental Systems. I've already talked about this before, but the arrangement again is the lectures and podcasts for the entire chapter on the first slide. The second slide is your learning targets for the week. So at the top, don't forget your learning targets up here on the week at a glance, tell you what I want to accomplish. It tells you the tasks we're going to do to try to accomplish those targets. And then it gives us how you would be successful. So what does it look like if you successfully got these 3 targets done? So that's what that is at the top. It's also for the whole chapter on here. So describe this, how matter is comprised. Like I said, a review of some chemistry, some basic chemistry, and we'll be doing some activities on properties of water, but we are going to do those after we finish our biodiversity lab. So we'll come back to this again. So you'll see this again as we enter other chapters and refresh on it. There we go. Somebody else got in. Good. All right. So Mono Lake is your case study. I'm going to go ahead and make sure you guys can see. Everybody should be on whiteboards. Yes. Okay. And yes, we talk to myself. Stop. There we go. Okay. I wanted to fill the screen. So we started this last week. Oh, I can't see your whiteboards if I do that. Sorry. Let's go ahead and put what you think the words are here onto your whiteboard. What occupies space and has mass? What is the measure of the amount of matter it contains? And then we're going to watch a really important concept just as a group, which is about feedback loops. TED-Ed does a great job and they're usually pretty short. So we're going to watch real quickly what are feedback loops. So go ahead. Yes, you can. If you guys have a PDF editor, you're more than welcome to do that. I just don't have access to any PDF conversion tool. It made a big giant mess when I tried to switch it to a Google Doc. So you guys go ahead and what are those two words? And I'll come back to that TED-Ed here in a minute after we review these first 16 slides. So I see Devin's answer. And Connor, good. Finboy, good. Great. Nice. Joseph even has some cactus decorations. It's usually a sign of I'm bored. Why are we going so slow? But that's okay. My sister once said, your classroom should be filled with all sorts of posters because when you're bored, then you can look around at everything. So I could tell you the different experiences people have, right, in the classroom. All right. Whoever's still trying to get in, help them. 29 of you now. All right. So yes, it's matter and mass. So this chapter talks a little bit about these different levels that scientists work at. So we have everything from physiologists that might be studying the function of the fish themselves to these bigger fishery managers. They're going to look at lots of different aspects, from the economics to how do fish reproduce, right? They have to take in all of that bigger. So your chapter kind of talks about a little bit about this system level all the way down to individual pieces and roles. What are these key terms? Smallest particle that contain the chemical properties of an element. And then the next one, composed of atoms that cannot be broken down further. And then the two that students get confused, I'm going to talk about how to distinguish them here in a second, which is the number of protons versus the number of protons and neutrons. So what are those terms in chemistry called? Mute myself. Okay, see a lot of people writing atom. And mainly, well, and the hint is there a periodic table of these for the other one. Somebody's still stuck. Let me go look who it is. Sorry, I'm going to X out of that because that's making nonstop noise. I don't know what to do to get them in. So hopefully they'll have this recording for them. All right, so I want to talk about atomic number versus mass number. That's still making a noise, so I have no clue why it's making a noise, you guys. Sorry about that. But mass is like, right, the total amount that we have that's taking up mass. And both protons and neutrons in chemistry are considered to have mass. So they're given an arbitrary thing that's compared to carbon of a 1 rating. So protons are +1, neutrons are a neutral 1. And electrons aren't counted because they're zero. Their weight or their mass is like 1/1800th of a proton or neutron. So it's just considered. So when we talk about your mass number for your whole atom, we have to take both the proton and neutron that's in the nucleus. So we call that mass number. Versus atomic number is something about how the properties are going to be and how it's arranged on the periodic table. And the properties, what matters really is the electrons and how they interact with one atom to another. And electrons equal the number of protons so that you are neutral. So I don't know why, but that tends to be one that students get confused a lot. Make a note, mass number, you're going to total two of the things that have mass in an atom, your protons and your neutrons. And then this is just showing you different ways to visualize it. So space filling models, orbitals, I really enjoy this kind of stuff, but most people don't care about electron clouds. I'm going to rule the world and how everything interacts. Okay, so here's another list of terms. When we talk about radioactivity, one of the skills that you should be able to do is determine this time that it takes for 1/2 of the original radioactive parent to decay. And there's lots of little activities we can do with this one to reinforce this and practice it. But there's a word for atoms with the same number of protons, but different number of neutrons. So they have more mass, but they're still the same element. So on your whiteboard, what are those terms? Yeah, some people are still having trouble on the whiteboards. I wish they could see the screen. That's interesting. They can get to my whiteboards, but they can't get to the actual Zoom. There shouldn't be any password. Okay, I'm still waiting for a few of you to tell me what some of these words mean. Mute this. If someone could also tell them, I thought that Xing out of that would make the noises stop, but tell them that I'm recording this so that definitely we'll have it afterwards. Don't know what to tell them about why it's not letting them on.
Yeah, I told them that you were recording it so they can watch it later. Okay,
thank you, Jessica. Because they're writing to me on their whiteboard, so I know, but they can't get in, so I don't know. All right, good. I see several of you. So this is a skill, kind of a basic math where you take things and figure out half-lives, and they give you some part of the scenario of what the half-life is, or ask you to determine it based on the parent material that's present and how long it takes for it to get to a stable state. So all of these different elements do this at different rates that are consistent. So you can kind of measure in time how long ago it existed, and we'll talk more about that later. All right, there's also a very, very short review about chemical bonds. So what are these different chemical bonds called? You are sharing electrons, so you're both using the electron to be more stable. So like hydrogen and oxygen. Hydrogen needs one more to be stable, right? Oxygen needs two more, so it shares from 2 hydrogens so that it has an octet. And then if you actually give up your electron and become charged, so if I give away something negative, I become positively charged. If I gain one, then I become negatively charged. It means I'm becoming something called an ion. So what type of bond is that when you suddenly make 2 ions and they're attracted to each other? And then bonds between molecules that have hydrogen bonds, that's what the TED Talk's on. It's called The Weirdness of Water. I think I gave you 3 different choices. I watched 3 different ones. It depends upon the level of detail you want, which one you choose. I think the last one was probably the most difficult in terms of its complexity and knowledge. It's from a scientist at University of Washington, though, in Seattle, and his studies with water. The other 2 are a little bit more general. And you can see the difference too between the same, I think I put 2 on there from the same guy, one where he's speaking to people at the University of Washington, one where he's speaking to a general audience, which is the TED Talk. So it's kind of interesting to see how they speak differently in 2 different audiences. And so he talks about this bond between molecules that have hydrogen bonds. And then water is considered this because one side is more positive and the other side is more negative. So oxygen is very big compared to hydrogen. And that means it has more protons. And that means it's an electron hog. So if you are positive, you pull negative things next to you. And so even though they're sharing and those electrons are moving around clouds and visiting the hydrogens and the oxygens, because oxygen is a big electron bully, it pulls them closer. And so it makes that half of the molecule more negative. So it's called a partial negative charge on one end. And then that also means the same thing on the opposite, that you're partially positive. If you are that type of molecule, you are given another term. So I'm just looking to see if anyone knows when one side is positive, the other is negative. What is that? What are you called? What kind of molecule? Oh, I see somebody. Kendall's got it. Good. And Joseph's got it. And Finboy, nice. And Haley, good. Connor, good. Sophia, see it, good. Addie. Okay. So when you share, it's covalent. Okay, so think of coworkers. They're working together. They're both sharing. They're both getting something out of it. Ionic really is because you're forming something called an ion. So if you give up an electron, you become positive. The thing you gave an electron to becomes negative. And sometimes if positive and negative are next to each other, they're going to be attracted. And that bond is an ionic bond. And then hydrogen bonds, you can hear a lot more about these as we talk about the next section, which is properties of water. So hydrogen bonds have a huge impact on our environment and in our And then polar molecules. So things like water are polar. They have poles. So they have one end is slightly different than another end. If you're coming up to that molecule, one end has more of a negative charge and one has a positive charge. And this just shows you how these electrons are being shared in like a covalent bond. So here's methane, CH4, and it's just showing you how hydrogens are being shared all the way around so that the carbon has 8 on the outside and it is happy. And this one's just showing you how that transfer of electron makes something negative and the other thing positive, which is salt. Sodium versus chlorine are very different, but than what salt is, right? Sodium's explosive, chlorine is like, will kill you, green gas. There we go, somebody just got it. All right, and this is just showing you this idea of polarity in a water molecule. So these electrons are spending more time. Now we can't, this isn't quite accurate if you really study chemistry because these electrons exist in probability fields, meaning if we ever know where it's at one time, it changes some other aspect of the electron. Like I said, I think this and other people makes their head hurt, but there's a lot of math that goes into explaining all of this, and that it doesn't really exist in a specified location. It just exists in a probability of seeing it in a certain location, and it's spending more time around oxygen than it is around this. It makes the molecule polar. Oops. All right. That's it. That's 1 through 16, because we're going to be moving on to properties of water next. So we're just going to watch one quick video clip about feedback loops. So pay attention to what a feedback loop is. You need to know the difference between a positive and a negative feedback loop, and why in environmental science they're important.
When school isn't a place you have to be.
In anatomy, we study these as well, because it's what keeps you healthy.
Testing, testing, 1, 2, 3. When your band is trying to perform, feedback is an annoying
And maybe we aren't going to watch this video.
obstacle. But in the grand orchestra of nature, feedback is not only beneficial, it's what makes everything work. What exactly is feedback? The key element, whether in sound, the environment, or social science, is a phenomenon called mutual causal interaction, where X affects Y, Y affects X, and so on, creating an ongoing process called a feedback loop. And the natural world is full of these mechanisms, formed by the links between living and non-living things, that build resilience by governing the way populations and food webs respond to events. When plants die, the dead material enriches the soil with humus, a stable mass of organic matter, providing moisture and nutrients for other plants to grow. The more plants grow and die, the more humus is produced, allowing even more plants to grow, and so on. This is an example of positive feedback, an essential force in the buildup of ecosystems. But it's not called positive feedback because it's beneficial. Rather, it is positive because it amplifies a particular effect or change from previous conditions. These positive or amplifying loops can also be harmful, like when removing a forest makes it vulnerable to erosion, which removes organic matter and nutrients from the earth, leaving less plants to anchor the soil and leading to more erosion. In contrast, negative feedback diminishes or counteracts changes in an ecosystem to maintain a more stable balance. Consider predators and their prey. When lynx eat snowshoe hares, they reduce their population. But this drop in the lynx's food source will soon cause their own population to decline, reducing the predation rate and allowing the hare population to increase again. The ongoing cycle creates an up and down wave-like pattern, maintaining a long-term equilibrium and allowing a food chain to persist over time. Feedback processes might seem counterintuitive because many of us are used to more predictable linear scenarios of cause and effect. For instance, it seems simple enough that spraying pesticides would help plants grow by killing pest insects, but it may trigger a host of other unexpected reactions. For example, if spraying pushes down the insect population, its predators will have less food. As their population dips, the reduced predation would allow the insect population to rise, counteracting the effects of our pesticides. Note that each feedback is the product of the links in the loop. Add one negative link and it will reverse the feedback force entirely. And one weak link will reduce the effect of the entire feedback considerably. Lose a link and the whole loop is broken. But this is only a simple example, since natural communities consist not of separate food chains, but networks of interactions. Feedback loops will often be indirect, occurring through longer chains. A food web containing 20 populations can generate thousands of loops, of up to 20 links in length. But instead of forming a disordered cacophony, feedback loops in ecological systems play together, creating regular patterns just like multiple instruments coming together to create a complex but harmonious piece of music. Wide-ranging negative feedbacks keep the positive feedbacks in check, like drums maintaining a rhythm. You can look at the way a particular ecosystem functions within its unique habitat as representing its trademark sound. Ocean environments, dominated by predator-prey interactions and strong negative and positive loops stabilized by self-damping feedback, are powerful and loud, with many oscillations. Desert ecosystems, where the turnover of biomass is slow and the weak feedbacks loop through dead matter, are more like a constant drone. And the tropical rainforest, with its great diversity of species, high nutrient turnover, and strong feedbacks among both living and dead matter, is like a lush panoply of sounds. Despite their stabilizing effects, many of these habitats and their ecosystems develop and change over time, as do the harmonies they create. Deforestation may turn lush tropics into a barren patch, like a successful ensemble breaking up after losing its star performers. But an abandoned patch of farmland may also become a forest over time, like a garage band growing into a magnificent orchestra.
All right, so that was kind of like a real basic general look at this idea of feedback loops, but it is a major concept that always comes up on the test. So before we, what I'd like to go to next is to talk to you guys about how to tag each other. So what to do in your breakout rooms. Yes, it is. It should be in today's, I can put it on here. I can hyperlink it in here. I have it on a daily lesson thing. All right, so we're going to go here, fact or fiction. We are not doing this whole activity. I just want to talk about tagging. This is an original assignment from about 20 years ago from University of Washington about why we should care about things like understanding science literacy and what the media says. So tag, you're it. Tag stands for, can you guys see that? Yes. Tell the writer something you like. Ask the writer a question is your A, and G, give the writer a positive suggestion. So you in your breakout rooms are each going to get about 90 seconds to share your claim, evidence, and reasoning, and then you're going to get 30 seconds to verbally tag people, and then 30 seconds to make a post-it where you actually put it on the poster. That way multiple people from that group can see it later. And you get put your name on this tag. And yes, this is linked in. But the only part of this I really want to talk about right now is this tagging format that we're doing today. The next thing I want to share, if it will let me, is kind of the roles. Let's see if this is sharing the screen. Here. All right. So somebody just asked about sharing that video, and yes, I can share that video on this sort of daily agenda. But procedure is going to go like this. Pick roles. So somebody be a timer, somebody be a document, like opens up a Google Doc and kind of records questions, different things that are said. Equity monitor, they're making sure everybody has a chance to speak and that no one's taking over. And reporter, okay, is going to be the person who reports out when we get back in a big group, or you can have someone who's just the first one to go. So it's up to you if you want to be the first to go or you want someone in your group to be a reporter. You're going to time the presentation, so your timer will time it, and then everybody has a chance to explain their claim, evidence, and reasoning on the Jamboards. And then 30 seconds for verbal feedback and 30 seconds to tag. Must have your full name on the post-it, and then you rotate to a new speaker and just repeat that whole process. And I will put this in the broadcast so that you guys have it. This says documenter, make a Google Doc, put all breakout room names and roles at the top, and you record any questions, concerns, ahas, just the general kind of transcript of what's happening in your breakout room. So whoever's a fairly decent typer can be a documenter. Right. So before we do this though, I want to talk about what you guys think should be, oh, it disappeared. Oh, we're gonna run out of time. What should be things that you would look for in a speaker's skills? So what are some things that demonstrate exemplary or proficient speaking skills. So unmute yourself or put it in the text box, although I can't see my text box. I will go open it. What are some things that we should look for in a speaker? How far in the future, chapter 2? Probably at least 3 weeks. There's a lot in chapter 2 that is unfamiliar to freshmen. So, and we have freshmen that haven't taken chemistry. Okay, so I see clear tone, eye contact, concise, okay, right? So you have 90 seconds, so you better be concise and on task, okay? Right, those are all good. I'm going to kind of write those down here in a second. What about the tagger? So the person, all of you are also giving feedback. What are some skills that demonstrate your proficiency? Okay, I see helpful, insightful. Good, what else? Give feedback nicely, okay, constructive. I'm guessing this is make it thorough and positive. Okay, I like that. There's another thing that when I'm scoring those that I look for, nice before the criticism. Yeah, what's that called? There's a word for that, something sandwich. Man, I'm tired. Compliment sandwich. Yeah, have you guys ever heard of a compliment sandwich? It's where you're supposed to give a compliment, then the criticism, then compliment. Okay, so it's called a compliment sandwich. All right, so clear. Yeah, and one of the things I look for is specific. So saying someone did a nice job really doesn't tell us anything. What is it that they did well, specifically? Okay, so that's what we're going to be doing. We're going to pull up the Jamboards, and then you'll, in your rooms, assign those roles and share your claims. If more than one of you have the same claim, then you can work together, okay, to share about it, since I'm going to do the rooms randomly. Any questions before we go to breakout rooms? Hopefully Jamboard will not crash us. Let's see. Oops, I'm going the wrong way. Breakout rooms. Two pretty big rooms today. So you can hear from a lot of different people. Your room should be open.
Okay, so who wants to go first?
Anyone? I can go first if you want me to.
Yep, you can go first.
Okay.
Okay, anyone else has any questions?
I do not.
Threat. Help reduce this threat because almost all US electricity is produced from domestic sources, including coal, nuclear, natural gas, and renewable sources. And then I just said these methods of powering are much better and safer for the environment than what is used to power gasoline vehicles. And am I supposed to read all of them?
I'm not so sure how many.
Okay. Well, they're kind of just all the same thing, just like.
I think you're just
Not
supposed to
really.
go until the 90 seconds is up.
All right. Well, there you go.
Where should we put the sticky notes? Because there's no more room on the Jamboard.
They can go right on top of things.
do we go ahead and leave? We finished everything. Do we just go ahead and?
Yeah, just we have like 1 minute unless oh my gosh. Okay, this is weird. My watch says 9:34, my computer says 9:38. So sorry about that. I don't know why my watch is not working correctly. Yeah, it's second period. I don't know why my stuff is so far off. We will talk more in our next live session about our tags. Why is this off? I don't know. Bye, you guys. Bye, Sophie.